Dear students, today I want to revise the properties of fluids. In this video, we can go through the pressure and the Archimedes principle in detail. See the very important terms in place of mass for objects. Here for liquids, we have to go through the concept density. In place of force for objects, for fluids, we have to learn what you mean by pressure. So here the density is nothing but the mass by volume. And keep in mind, for a solid body, the density of the body and the density of the material or the substance are equal. But the case is entirely different for a hollow body. The density of the body is less than the density of the substance. Reason, the volume of the body is greater compared to the substance. And see, the relative density or the specific gravity means the density of the substance by the density of water at 4 degrees Celsius. And keep in mind the relative density that can be measured by using hydrometer. See the two different problematic situations, and especially during the case of if two liquids are mixing. See, if two liquids of masses M1 and M2 with the densities ρ1 and ρ2 are mixed together, then the density of the mixture is given by, so just the total mass by the total volume. Here the importance goes to masses, so the density is nothing but the total mass M1 plus M2 by the total volume V1 plus V2. Here in place of V1 as its mass by density M1 by ρ1 plus M2 by ρ2. But if you just take as M1 equal to M2, you get the harmonic mean of the density is equal to 2 ρ1 ρ2 by ρ1 plus ρ2. If two liquids of volumes V1 V2 with the densities ρ1 ρ2 are mixed, then the density of the mixture is nothing but is equal to again the total mass by volume. But here in place of mass we can express in terms of volume as V1 ρ1 plus V2 ρ2 by V1 plus V2. If V1 equal to V2, you get the arithmetic mean of densities ρ1 plus ρ2 by 2. You know the pressure? The pressure means it is the magnitude of normal force per unit area and is expressed in terms of Pascal or Newton per meter square. And keep in mind some practical units. The atmospheric pressure, the pressure exerted by the atmospheric column on the surface of water, so that is 1.01325 into 10 raised to 5 Pascal. 1 bar take the value as 10 raised to 5 Pascal. 1 torr take the value as 1 millimeter of mercury. And 1 atmospheric pressure again equal to, you can express in terms of height of water column as 10.33 meter of water. So that is a pressure. And keep in mind the 3 types of pressures we have to deal: atmospheric pressure, absolute pressure, and gauge pressure. We know the atmospheric pressure, and that is measured by the barometer, maybe based on the Torricelli's experiment. And keep in mind in terms of the height of the mercury, it is 76 centimeter of mercury. The absolute pressure or the hydrostatic pressure at a depth h below a liquid got 2 contributions. One, the atmospheric plus the height of the liquid, and that is expressed as h rho g. So the absolute pressure or hydrostatic pressure is equal to P0 plus h rho g. The gauge pressure, it is the pressure difference between the hydrostatic pressure and atmospheric pressure, or it is the excess pressure over the atmospheric pressure. So it is measured by the manometer. So look here. So that is nothing but Pa minus P0. So that is equal to H rho G. H rho G. So that is gauge pressure. Look the two different vessels. And here the different structured vessels are communicated. But keep in mind the pressure at the point B and C are equal because of the height are equal. And the different volumes are taken in different vessels. But the height are same, and hence we can say PS should equal to PP. A very important concept. Pascal's law. A liquid exerts equal pressures in all directions. If the pressure in an enclosed fluid is changed at a particular point, the change is transmitted to every point of the fluid and to the walls of the container without being diminished in magnitude. That is a speciality. Based on that concept, so many applications are there, like hydraulic jacks, press, lift, brakes, etc. So here, the hydraulic lift. At every point, the pressures are equal. So for the two pistons, we can say F1 by A1 should equal to F2 by A2. There, A1 and A2 are the corresponding areas. The very important concept, buoyancy and Archimedes principle. When a body is immersed partially or wholly in a fluid, it experiences an upward force due to the fluid surrounding it. That upward force is equal to the weight of the fluid displaced by the body. Weight of the fluid displaced by the body. So that is upthrust is equal to buoyant force is equal to volume inside into the density of the liquid into G, and is acting in the upward direction from the center of buoyancy, the center of the liquid structure. And keep in mind that upthrust is purely depends upon the volume, not on its structure, its shape, and also the nature of the liquid, the fluid under consideration, and the value of acceleration due to gravity. And keep in mind, in a lift, it is moving upward with an acceleration A. The gravity changes to be equal to G plus A. If it is downward with an acceleration A, it is G minus A. From based on that upthrust, to keep in mind, we can easily find the relative density of the body. So that is the density of the body by the density of water. So we can easily find that is weight in air by the weight in air minus weight in water. The relative density of the liquid means the density of the liquid by density of water. Again we can use. So the very important concept. We can move with some problematic situations. Look, a hollow metallic sphere has inner and outer radii as 5 and 10 centimeters. If the mass of the sphere is 2.5, find the density of the material, relative density of the material. So at first we can find for a hollow spherical one, what is the volume? So the total volume minus the inner volume. So 4 by 3 pi into R2 cube minus R1 cube. So all the parameters are given. So if we know the value of volume, the density we can say as a mass by the volume. So you get the value. Then what is the relative density? The density of the body by the density of water, that is 1000. You get the value as 0.6812. A simple concept. The two immiscible liquids of density is 2.5 and 0.8 are taken in the ratio of their masses as 2:3, then find the average density of the liquid combination. The density is nothing but the mass by volume. The total mass is what? As 2m plus 3m by the volume in total. For the first one, what is the volume? It's mass by density. And similar to the second one, so you get the value. So that concept is very important. Calculate the depth of a well. If the pressure its bottom is 15 times that at the depth of 3 meters. Atmospheric pressure is a 10 meter column of water. So it is equivalent to the pressure exerted by the 10 meter height of water. So we can say if H is the height of that depth of well, so atmospheric pressure plus H rho G should equal to 15 times that due to the 3 meter depth. So While substituting like that, so you get the answer as 185 meter. And another very important question. A U-tube contains water and methylated spirit separated by mercury. The mercury column in the 2 amps are in level with the 10 centimeter column of water in 1 amp and 12.5 centimeter column in spirit. What is the specific gravity of spirit? And here the mercury are in same height, and hence we can just equate the contribution of different liquids in the 2 amps. So for water and for spirit. So atmosphere cancel. So you get the value. The specific gravity of spirit means the density of spirit by the density of water. And here a vertical U-tube of uniform cross-section contains mercury. A glycerin of relative density 1.3, column of length 10 cm is introduced into one of the amps. Oil of density 800 kg per meter cube is poured into the other amp until the upper surface of the oil and glycerin are at the same horizontal level. Find the length of the oil column. Carefully read the question. So this height are equal for the cases. If you just take these 2 points, here also by because of Pascal's law, on a horizontal level we can say the pressures are equal. So due to the 0.1 meter height of that liquid is equivalent to the pressure due to this height. So but here this is 2 contributions. So 0.1 meter. So that is a glycerin. So atmospheric pressure plus that pressure. So that is a 0.1 into the density of that much into 2 is equal to that due to this much height. So P0 atmospheric pressure plus this height. This height is nothing but here. It is with the mercury. So 0.1 minus H into 13.6 into 10 raised to 3 into G plus this height of that density is oil is density is given as 800. So that's a substitution. So just we can find the value of H. It's a good aspect to keep in mind. On a horizontal level, the pressures are equal. A hydraulic automobile lift is designed to lift carts with a maximum mass of 3000 kg. The area of cross section of the piston carrying the load is 425 cm square. What maximum pressure would the piston have to bear? The pressure is nothing but the force by area. Simple substitution. And here in order to lift 3000, so the weight become into G. Very, very important concept. You can write one question based on that principle of flotation. See, when a body of density rho and volume V is completely immersed in liquid of density sigma, and keep in mind the forces acting on or the weight of the body W is acting vertically downward from the center of gravity. The upthrust that is acting vertically upward from the center of buoyancy. Look the 2 values. We can arrive with 3 cases. The first one, the density of the body is greater than density of the liquid. The weight of the body is greater than upthrust. So the body will sink to the bottom of the liquid. So there the apparent weight become W by thrust. V rho G minus V sigma G. So we can take as V rho G into 1 minus sigma by rho. Or the weight in air into 1 minus sigma by rho. So second and third cases are very important. What happen if rho is equal to sigma? The body will float fully submerged. That is what is called the neutral equilibrium. There the apparent weight becomes 0. If the density for the body is less than that of the water or the fluid under consideration, the weight in air is less corresponding to the thrust. Because of the thrust, that body is come out of the water or the fluid. So the body will float partially submerged in the liquid. Because of that pushing concept, in this case also the apparent weight becomes 0. And the both cases are said to be the laws of flotation. We can move with some important concept regarding that floating concepts. See, the 2 important questions are here. One, A piece of m gram of ice is floating in a liquid of density royal. Then what happened if m gram of ice melts? But if that density of the liquid is equal to density of water, the level remains unchanged. The density of the liquid is greater than density of water, the level will rise. The density of the liquid is less than water, the level will fall. And similar question again, a big rectangle full of water has an ice piece containing air bubble or lead piece or cork piece. And keep in mind, air and cork less denser than the liquid, but the lead got more density than liquid. So in that two cases the level remains the same. But for lead piece the level will fall. The two extra concepts for especially main aspirants, fully submerged body may be in rotatory equilibrium with the three cases. The neutral equilibrium in the sense, keep in mind, and there the center of gravity and the center of buoyancy should coincide. If you give a small tiltation, that point never changes and hence the body is under neutral equilibrium. If an additional weight is given to the top, then what happening is this one, the center of gravity location changes to the top, and if you give a small jerking to that one, and that center of gravity will give a more force to the downward direction, and hence that body will sink to the bottom. Therefore it is under unstable equilibrium if the center of gravity lies above the center of buoyancy. But for the stable equilibrium, keep in mind here the additional weight is on the bottom, and hence if we give a small jerking on it, it will produce an equal torque and it will come to the original position, and hence it is a stable equilibrium. But for a partially submerged body is stable as long as the center of buoyancy lies below the meta center. And keep in mind the M is the point of intersection of the shifted line of action of the buoyant force with the original line of action of buoyant force. So that is a very important concept. See some problematic situations. A cubical box of wood of side 30 centimeter weighing 21.6 kilogram floats on water with two faces horizontal. Calculate the depth of immersion. You know the floating condition. The weight should equal to upthrust. So what is the weight? So that is nothing but its mass into G equal to upthrust volume inside. So X is the depth of immersion there. So we can say X into the 30 into 30, that is its side. Have to express in terms of CGS, you get the answer. A good concept. A block of brass of mass 0.5 kilogram and density 8 into 10 raised to 3 kilogram per meter cube is suspended from a string. What will be the tension in the string if the block is completely immersed in water? You know, in air, the tension is nothing but the weight. But when it is immersed fully in water, there should be upthrust. So the tension is W minus thrust, mg minus thrust, mg minus volume into density of the water into G. So you get the concept. A log of wood floats in water with 1/5 of its volume above the surface. Then what is the density of wood? So W is what? That is equal to the thrust. Therefore, we can say volume into density of the body into G is equal to volume inside into density of water into G. You get the answer simply. But you can use the two shortcuts. The fraction of volume inside, V in by V equal to density of the body by density of liquid. The fraction of volume outside, V out by V is equal to 1 minus rho B by rho L. It is a very important concept. Two good questions. A body weighs 160 gram in air, 130 gram in water, and 136 gram in oil. What is the specific gravity of the oil? So that is nothing but the loss of weight in oil by loss of weight in water The loss of weight in oil means weight in air minus weight in oil. So that is a very important concept, so you get the value. A cubical block of iron edge 5 centimeter is floating on mercury in a vessel. What is the height of the block above mercury level? So it is simple. You can show the weight is equal to upthrust, the weight. So the whole weight, the whole volume into its density into G is equal to. So inside it become x minus h into density. So here one x square is there, x minus h into x square is here. So x square into the density of mercury into G. So by solving you get the value as 2.35 centimeter. But the next question, water poured into the vessel so that it just covers the iron block. What is the height of water column? So what we can say, so by looking into the figure, the water is filled with of y height. So the weight can be written as s cube into density of the body into G is equal to. So at first, what is the upthrust due to this one and then water? So with respect to the mercury, we can say x square into this depth, that is x minus y into the density of mercury into G plus, then above that is water. So x square into that height, y into the density of water into G. Just a solution, you get the value. So the properties of fluids, it is a very, very important topic. You can wait minimum 3 questions for NEET entrance exam. Minimum 2 questions for JEE. For KEAM, it must be 4. So you must go carefully for last, especially the second volume questions. So God bless you. Take care.